Okay, our next topic is spanning tree protocol. If spanning tree is not happen in our network, what will happen? We'll discuss and if what it will be do. Basically, spanning tree protocol, it's for the avoiding the loop in between switches. Like in LAN switches, basically switch what it will be do, it will be broadcast the information whichever the sending from receiving from LAN means the LAN said end users will forward the frame packets through switch. Then switch what it will be do, it will be broadcast the information entire the LAN side. It's kind of your LAN. Then how many ports are connected for this switch? This PC sends some information to PC4. Then this switch what it will be do, it will be broadcast the information. That is, we call it as a broadcast streams, broadcast to every PC. Likewise, if switches also connected, it will broadcast the information. If here it is broadcasting the information like with the help of MAC. Okay. If we have one link, then the switch is connected. This switch is broadcasting information to this PC and this PC or this PC. So if this link goes down, in between we have a connectivity. It's first floor switch and this is a second floor switch. They are communicating to each other at LAN side. Okay, this is a different department and this is a different department. You can assume like they are communicating to each other properly. If this link is goes down, then in between they cannot communicate to each other. If link goes down, so we need a redundant link. We need a redundant link. If this link goes down also, we have the redundant link. The link will be up. Then we can easily communicate at different floors. So basically switch what it is doing, broadcasting the information. So it is getting the broadcast from here. Then again, same packet. When the redundancy link is there, both are up state. Both are in working fine now. Whenever the link goes down, that is the different concept. And here I am explaining different scenario that if this link goes down, we have a redundant link. Okay. If redundant link we have, then what will happen? Now you understood, guys? If redundant link is not there, we cannot communicate to each department to this switch and this look, this first floor to second floor. It's a campus type network. So if this link is goes down, also we can communicate to each other. So if though both our links are working fine, both our links, redundant link also working fine, and for first primary link and secondary link both are working fine, then what will be happen? Switch what it will be do, broadcast the information, whichever the information she will get first link, primary link, and second the information broadcast to everyone. Here also it will be. So what was the happening here? So the broadcast room again it will be sent. Then the switch received the broadcast room. It originated this switch only. Again, this switch is getting the same information here. Likewise, here CPU utilization and loop will be generated here. If multiple links we are using, that time broadcast room will be happen. So loop will be generated when we have a redundant path. If one path in between, that time no issue. If we don't have, then also we have a issue, like if this physically this link goes down, the damage it will be happen, this physical connectivity, some broke down, something happened with that. So we have a issue. If not there, also if it is there also we have a issue, because broadcast wrong will be happen. So that is the reason spanning tree is the protocol to avoid this kind of loop, then our network connectivity is properly work. It is by default enabled in Cisco switches. I hope everyone got the concept of what is the requirement of spanning tree. If you are not understood, I'll explain again.
Only avoiding the loop in only in the switches, right?
Yeah, only LAN side in layer 2. It's a basically layer 2 protocol. It will work only switches, not in layer 3 protocols, right? Routers. Fine. This all about the go through these steps we have. Spanning tree protocol uses spanning tree algorithm to avoid the switching loops in layer 2 devices. Bridge and switches. Earlier, bridge we call switch is nothing but bridge only. And earlier in legacy network, we call it as a bridge. Nowadays, we are calling as a switch only. But even though the terminology is same thing. And STP work when multiple switches are used with redundantly avoiding broadcast ROMs, multiple frame copies, and database instability. Those what we discussed here. Same thing. If redundant link is not there, then we have a issue. If redundant link also is there, it will be generate multiple broadcast frames, broadcast ROMs, multiple frame copies. Frame copies where it will be generate frames actually in data link layer. It's layer 2. Database instability. And first developed by DEC, Digital Equipment Corporation, in 1985. And STP is an open standard protocol. It will work in Cisco devices as well as in non-Cisco devices like HP, Aruba, Palo Alto. Every switches the STP will work. It's an open standard. But STP is enabled by default in all Cisco switches, in all Cisco Catalyst switches. Okay. STP process under in 3 steps. Actually, STP, whenever the establishing, there we have a, see, I'll take an example here. Whenever the STP is establishing at multiple switches, in this case, what will happen? We'll discuss. So how the STP will work. Selecting first one, it will be select the root bridge. Then it will be select the root port, and it will be select the designated and non-designated port. Designated port, it's we call it in later on session DP, and non-designated port means it's blocking port. And we have a root port. Here we have 3 types of port: root port, designated port, and non-designated port. Non-designated port means blocking port. Okay, first it will be elect as a root bridge. First, it will be select as a root bridge. If we have here multiple switches, switch 1 and switch 2, here we have a switch 3. So how it will be select? Switch will select based on the priority plus MAC address. First, it will be elected as a root bridge. How the root bridge election will be happen? First, we'll discuss those things. How the root bridge election will be happen. See, I'll take it is here 3 switches. So first, how it will be the bridge with the best lowest bridge ID. Bridge ID. The bridge ID nothing but the whichever the switch it is having the lowest priority plus lowest MAC address. Basically, we have a priority every switch and having by default priority is 32768. 32768 and they're having the MAC address like this switch having like will this we can assume it's a 0A and this one is 0B and this one is 0C. Basically MAC address is 48 bits, but I am taking only simple manner. So 3 to sorry 32768 plus MAC 0A and the MAC address of this PC 32768 plus 0B and this is the MAC address of 32768 plus. So whichever having the lowest MAC address, first it will check priority lowest priority plus MAC address. So by default, we have a 32768 by default priority. So all the switches having the same priority. So priority will tie. Then it will be moved to the MAC address. MAC address will be not tie here because every device having the unique MAC address. So whichever having the lowest MAC address, that port elected as a root bridge. That port bridge elected as a root bridge. That bridge only send the BPDU packets. Bridge protocol data unit. We'll discuss that thing. Based on the priority, it will be based on priority plus MAC address elected as a root bridge. Out of all switches in network, one is elected as a root bridge that becomes the focal point in the network. Every LAN will have only one root bridge and all the remaining switches will be considered as a non-root bridge. Only in LAN segment, in LAN network, we have only one root bridge. Apart from that, if you have 100 switches also, if you have how that like distribution switch, core switch, and we have a access switches. If you have 100 of switches, we consider as a distribution or core switches as a considered as root will make it as a that is the root bridge. Apart from that, access switches will make it as a non-root bridges. The root bridge only it will be that bridge only having the designated port. We'll discuss what is the designated port, but that bridge only send the frame packets. If any topology changes also, that root bridge only send the entire topology change messages. Any network topology also. In a LAN network, only we have only one root bridge. Apart from that, all are the non-root bridges. This is all about root bridge. Anyone have any queries in root bridge?
Yes, how it will go to first to the priority, then it will go to check the MAC address of the switch, right?
Right.
So first it
First,
will
it will be
priority
yes,
on
yes.
what basis it will?
We have a by default priority that is 32768. 32768 by default priority. Every switch having the same priority because STP algorithm here we are using that STP algorithm. We have a 32768 by default priority. So every switch having the same priority. So though then in priority basis we cannot elect as a root bridge. So we'll elect as a root bridge as a MAC basis. So
On
MAC
MAC address
addresses.
on MAC address basis, we'll select the root bridge.
Yes. If you want to change the priority, say okay, fine. If the by default priority is 32768, you can change this as a 0 also. If you change this priority as a 0, then 0, it's a lowest priority compared to two switches, then it will be elected as a root bridge. This one is a root bridge. Now this one is a root bridge. Because your priority is 0. You can change the priority also. If you want to make it as a this every time to this switch as a root bridge, you can change the priority. You simply it is always it is elected as a root bridge. If you have like distribution switches here, and this is the all access switches. So in access switches, we'll use like this is means they're having the lowest configuration protocols, like they're having the less. So in access port, just will create the VLANs only. So we'll take it as a less versions of switches, and prices also less, 1900 or 2600. This kind of switches will use. In distribution layer switch, we'll use like 3K switches. These are the catalyst switches, 3K or 4K switches will use. So always will use priority less compared to these switches. Will always these bridges are the root bridge. This one is the secondary root bridge. Will make it as if this bridge is goes down, then it will be select as a this is the primary root bridge, and this is one of the secondary root bridge. If this bridge is goes down, then automatically it this secondary root bridge elected as a primary root bridge. The connectivity likewise. These are distribution switches, and this is the access switches. So here we just will change as a priority less compared to this access switches. In real time, we'll use likewise only. Clear? But it will be by default priority is 32768, and if priority is tie, then it will be moved to the MAC address. Fine. Then root port. What is root port? See, before that, this switch having designated port. We'll discuss, and root port as like this is a non-root. So here first we'll take it as a this one is the only root bridge. For example purpose, I have taken this. So we haven't changed the priority here. Same priority by default priority is there. So this is a root bridge. This one is a root. bridge. So root bridge having the designated port. Designated port only originated the traffic, originated the frames. Which frames? BPDU frames. In BPDU frames, what was the content will be happen in that protocol, which protocol we are using, which version we are using, which version of switches we are using, protocol version, and which type of field it is going, which flags are originated, which one is the root bridge. It will be in BPDU only DP port as generate the superior BPDU. It means bridge protocol data unit. When switches advertise BPDU, they place their switch ID in this BPDU. Means whenever the root bridge only generate the BPDU packets, in that BPDU, it's nothing but message. That message are BPDU packets, message or frames. In that, what content will be happen? Protocol ID, which version of switch, type, which type of fields, means which VLAN IDs and all, and which flags, root bridge. I am the it will be sell like I am the root bridge, and cost. Cost means every link having the cost. Cost is nothing but again speed, bandwidth you can assume. And which one is the designated port? I am the designated port. DP is nothing but designated port. And how much time to forward the message? Max age 20 seconds. In lab, I will show you that. And which message? Hello timer 2 seconds. Every 2 seconds, the BPDU will be send the hello packets. That will be DP port. After DP port, we having the one more port is root port. The link directly connected to the root bridge. A shortest path to the root bridge. First, here we have a like first it will be elected as a root port. That root port, whichever the shortest path, to the root bridge, that will be elected as a root port. Every non-root bridge looks the best way to go to root bridge is for every non-root bridge there is a only one root port. See, this one is the non-root bridge and this one is the non-root bridge. Both are non-root bridges here. This one is a non-root bridge and this one is also non-root bridge. This one also non-root bridge. Only in LAN segment, LAN network, we have a only one root bridge. Apart from that, all the bridges, all the switches, non-root switches, non-root. Okay, these all are the non-root. This one also, this one also. And non-root bridges having the only one RP root port, only one RP, only one root port, not two. This is and one. This one is the RP and this one is the RP. Not likewise. If only one RP we have, because RP will receive the frames. Because RP will receive the frames. Who will generate the frames? All will send the frames. DP will send the frames. RP will receive the frames. In non-root bridge, we have only one RP root port in non-root bridge. If we have multiple paths also. If we have multiple paths also here. Multiple paths also. In this path, here we have three paths. Here we have three paths. Here we have three paths. If we have three paths also, in the three path, only one RP, only one root port. Apart from that, these two are the blocking port. Only one RP. If here one RP is there, then these are the two blocking ports. If we have one RP here, then here two path are the blocking ports. Only in non-root bridge, only one RP will available, one root port available. Every non-root bridge looks the best way to go root bridge. For every non-root bridge, there is only one root port, and root port will be decided based on the following conditions. Based on the following condition, the root port will be elected. First one is least cost, and the bridge with the best lowest switch ID and lowest physical port number. What does that mean? Here we have three switches as we discussed. This is a root bridge. This one is a root. Based on the, it will be elected as a, this switch one is elected as a root bridge based on the which criteria? Lowest lowest priority plus lowest MAC address. So if you have any queries, ask me. Fast Ethernet 0 by, anyway, I'll show you in the lab. Before that, we'll discuss here 0 by 2, and if Fast Ethernet 0 by 1, and this one is a Fast Ethernet 0 by 2. So lowest fast Ethernet having the different cost, and Ethernet having the different cost, and see here Ethernet port having the cost that is, I'll give you that. This is the cost. Ethernet having the 100 MB 100 cost, that is 10 Mbps, and fast Ethernet it is 100 Mbps, the cost is 19, and gigabit having the 1000 Mbps, the cost is 4, and 10 gig having 10,000, the cost is 2. This is by default cost. So it will be whichever having the less cost. If you see here, you're having the less cost from root bridge. This is the DP port, and this one is a DP port. designated port, and these are the RP. How it will be elected? DP opposite to DP opposite, having DP opposite, definitely the RP. This is a root port, and in between one port will be block. In between one port will be block. How it will be elected? Based on the priority. I'll show you that. The root port will go to, third one is here, designated and non-designated port. Selecting designated point, non-designated port. Designated port will be always forward mode, and non-designated port, all ports are ports which blocked by the STP avoiding switching loop, and non-designated port will be always blocking port. See here, now it will be elected. One is the blocking port and one is the, here we have a port roles. In that port roles, one is DP designated port and one is RP, one is that is root port, and one is alternate. Alternate is nothing but blocking port. Okay. I'm not explaining here states. I'm explaining the roles, port roles. In that port roles, one is DP, designated port only, forwarding mode always. Forwarding mode. And RP, it will be receive the frames, and one more non-designated port, it will be blocking state. So how it will be elect in between? One is the blocking. Definitely here block is not happen. Again, loop will be generated here. Loop will be generated. Why? This frame will be originated the traffic from here. Once this receive, then it will be sent to frames this switch, and this switch is sent to again this switch. Again, this switch is sent to this switch. Likewise. Definitely, we need a one port will be block here in this topology. So how it will be happen? Based on the lowest cost. So here you can check this, here we are using fast Ethernet. So cost is 19. So here 19 and here 19. Here also this one is also fast Ethernet 19. Now tell me if likewise it will be going. So 19 may plus 19 for 38. Here also, if it is going likewise, here also 38. This is a port is originating, once receiving, this is the cost 19 here, and once it's sending, this is a port 38 will get, and for this we'll get here 38 cost. So definitely one port will be blocked here. How it will be blocked? Based on the above, whichever the originating the here, which one is the lowest port ID, physical number port. See here, lowest physical port number. Which one is the lowest physical port number? Based on that, which one is sending, the deep forwarding the packet, forwarding the preference. Based on that, it will be which one is the lowest. For that, it will be based on, it will be elected as a root port. Now this is originating, so 1919 also no issue for, but based on the this port number, it will be elected as a, again, DP designated port. This one is the blocking port, alternate port. Blocking, it means alternate. How it will be elected? This port will be blocking. Don't go. This is the port is low compared to less physical number, physical port. Don't see likewise. See the whichever the frames is originating. Go through that. Any doubts? Any doubts up to here? How it will be alternate? This is the port roles. Guys, if you are not understanding, ask me the questions. And in BPDU, what will be happen? What is a BPDU? And all switches exchange information through what is called as BPDU, Bridge Protocol Data Unit. All switches exchange information through what is called BPDU, because who will originate the BPDU? DP, designated port only. What content it will be happen? Protocol ID, version, and VLAN information, cost, designated port, forwarding, and message type, everything. Everything will send its kind of message. BPDU is nothing but message. BPDU contain a lot of information, help the switches determine the topology and loops that result from that topology. That what we discuss. And BPDU are sent every 2 seconds. Every 2 seconds, the BPDU message will be forwarded through DP port. RP will receive. We having a port states in BPDU. We having a 5 states in spanning tree protocol. We have 5 states in spanning tree protocol. First is blocking, second listening, learning, forwarding, and disable. In blocking state, it will be take 20 seconds or no limit. And in listening state, it will take 15 seconds. I'll prove it. And learning state, it will be take 15 seconds. After then, it will be forwarding state. And who will be forward? The DP and RP. RP ports are the forwarding state. One is the alternate is the blocking state. Blocking, we cannot forward or cannot receive. It will be only means it will be block the information, not send and not receive. If this port went down, then it will be a topology change occur. Then it will be moved to the up state. It is not a permanently block. It is not a down mode. Means the port is down, not likewise. It is a blocking state. That is, I'll show you in lab. Orange color it will be. We'll check. This is the STP ports: blocking, listening, learning, and forwarding and disable. We'll discuss each and every port. What will happen here in port rules, port states. Blocking won't forward frames. It will be listen to BPDUs. All ports are in blocking state by default when the switch is power on. Once you power on the switch, all the ports are blocking. Then it will be moved to the listen state. Listening state, BPDUs to make sure no loops occur on the network before passing data frames. And learning, in learning, MAC addresses build MAC table but does not forward the frames. In learning state, the switches will build the MAC table here only, but does not forward the frames. In forwarding state only, that send and receive will be happen. All the bridges will send and receive. If you have any queries, ask me. Otherwise, we'll move to the lab for this. What we discussed till now, I'll prove it that in lab. If you have any queries,
What if we add any another switch in the middle of the process?
You mean to say topology change? New switch
Exactly.
we connected.
Exactly.
Fine. Okay. Apart from that, anyone having any questions? We'll see in lab that, okay, what will be happening. But if that switch having, the less MAC address, that will be elected as a root bridge. So those things we will not see near our topology. We have a here uplink first, and that concept I'm planning to discuss in later on, but you are asked the doubt, I'll explain. But that is the different scenario actually. That topology change will be occur. Whenever the topology change will be occur, then we'll use as like backbone link, backbone fast or uplink fast will use. When the you connected like directly, this is the road bridge. This is a road bridge. You connected like one more switch here, that having the 32768 place less than this MAC address of this, like you can assume 0 1. So compared to this having the less MAC address, so it will be here topology changes occur whenever you will applying here uplink fast. So that cases it will be denied for this, because here we have the root switch. The root switch only originating the every data packets like BPDU frames. So we cannot do likewise in real time, but we'll use like one command in that uplink fast. Backbone fast will use like topology. Here topology changes occur, right? So we have a different advantage. Understood? Was this question? Guys,
Can we set this, like priority in switches? Like how can we set that priority? Like the default value is
priority.
26968. Yeah,
Yeah, we
the
can change
default
it.
value
We
is
can change
there.
it.
Can we set it?
Yeah, we can set it like 0 or
Okay.
096 plus again 4096, like
Okay.
80 something value. We can place on 4096 plus 4096 likewise plus
Like if
4096. We
it's
can say.
if we
Yeah,
have whole tree of like this, like a switch, like whole big loop in a system. So do we assign it or how we set them?
some noise is coming. I haven't listened proper your question.
Like if it is a big loop, not just three switches, but at least like 100 switches are there in the loop,
Mm.
then
You have 100 switches. Okay, continue. What will be happen if root bridge is not elected? You mean to say, 100 switches are there? It will be elected based on the MAC address and based on the priority. Lowest priority first it will be typed, then it will be moved to the priority. So MAC address. If whichever having the lowest priority, that will be elected as a root bridge. That
No matter how many switches, 100, no matter,
yeah,
irrespective of the
only
number
in
of
LAN
switches.
segment. Yeah, Mirza, in LAN segment, we have only one root bridge, not apart from the 2, 3, 4, 5, 6. Only in LAN network, I mean, earlier I said, right? In LAN segment, only one root bridge. If you have 100 switches also, even though you have 1,000 switches also, in LAN, in campus network, only one root bridge. Apart from that, we have a secondary root bridge. If primary root bridge went down, then we have a secondary root bridge. Now got it, Akhil? Okay, we'll check in lab. And we have a types of topologies in topology changes in happen here. We'll discuss. See, I'm taking here 3 switches. By default, STP is enabled on all switches in Cisco switches.
We are unable to see your screen. It's still on the board.
Sorry. No?
No.
No, we can't see the screen.
No, it's visible?
Yeah, yes.
Yes, yes.
Sorry. I'll delete this again. I'm taking here 3 switches. As I mentioned, by default, STP is enabled in switches. See port modes, you can check here. Down to it went to orange color. It is trying to election. Okay, now you can check here. So by default, STP enabled shows spanning tree. Now these all are the listening state. Listening, it will be take 15 seconds and learning also 15 seconds. Now both are in learning states. It also take 15 seconds and now it will be moved to the forwarding state. It was taken 45 seconds. It will have taken 45. 20 seconds for blocking, 15 for listening, 15 for learning. So minimum 45 seconds, or you can assume 40 seconds also sometimes. This is also 15 seconds you can assume. Minimum 45 to 50 50 seconds it will be take. Minimum 45 to 50 seconds, sorry. So these are the states we have. First one is disable. It is a red color. Then listening, learning, then forwarding, then blocking. Which one is the blocking? This one is the blocking. Why it is blocking? We'll check the. It is now still orange color only. Once this port went down, then it will become move to the. It will be green color. We'll check those things also. But now you can assume like one is disabled to learning 15 second. This one is a 15 second. Minimum 30 second it will be take. STP topology happen when after 30 seconds. This is a 15 seconds, minimum 15 seconds. So now which one is the root bridge? How we'll check? Which one is the root bridge? How we'll check? First, based on the priority having here 3 to 7 6 8, but here showing 9. Don't confuse it. By default VLAN 1 is here, so priority is like 32768, but and system ID exists, that is VLAN 1. Add on here 32768 plus 1, that is 32768 32769. Understood? Plus 1, VLAN 1. If you have VLAN 10 number, then 32768 plus 9. So 32778. The value will be likewise. Here 10. The value is 10. Add and the place value.
It has multiple VLANs, then
Multiple VLANs means if you can create here multiple VLAN. I'll show you that. If I'll create the multiple VLAN, then every VLAN having different instance. This is, we call it as a one instant. If we have one more in VLAN 10, that is one more instance, and we have a one more VLAN, then that is a VLAN 20. Again, we have a one more instance.
okay.
So we'll check first which one is the root bridge. This bridge having the MAC address is, this one is the MAC address, bridge ID. Wait. This is a root bridge information. You can check here root ID, root bridge information. This is the this switch information. Whichever this switch is there, that is this is a switch information. This is not a root bridge. This is a non-root bridge. Because here we can check the priorities, all the priorities. The priority of this switch is 7 to.
How we can differentiate between the root bridge and non-root bridge?
Yes, I am differentiating. I'm showing that only. The priority is show version. You can check show version. In this version, you will find out the MAC details 7239. Because same priority they having the switches. As I mentioned, every switch having the same priority, that is 32768. The priority is tie here. So show version. You can check here this priority E778 MAC address. That is the MAC address. Enable show version 3485. You can check here 0002, and this one is the highest than the D here and E here. So which one is the less priority having in these three switches? In these three switches, which one is having the less priority?
Okay.
This switch. This we
Yeah,
can
switch.
write the switch 1 and switch 2, and this one is a switch 3. So here we have a switch 1 is less priority. This one is a switch. We have less MAC address. Sorry, MAC address is less here compared to these switches. So we'll check here No, show spanning tree. And as I mentioned here, the switch is mentioned. This bridge is a route. This bridge is a route based on the MAC address. Understood? And this is the details of this feature. This is the details of route bridge. And this switch having hello timer every 2 seconds. This switch will originate the PPDO and max age is 20 second and forwarding delay time is 15 second. Aging time is 20 seconds. After 20 seconds, it will be not originate the packets, that switch, then the switch will be moved to the considered as is down. This switch is considered as this switches because we have big topology means we have multiple switches means they are connected likewise. If this switch is not originating the frames after 20 second also, so the switches cannot transfer the frames to neighbor switches. So that is also issue. So it will be wait only 20 every 2 seconds it will be checked. If it is not sending, it will be wait for the 20 second again. Aging time. So this port is DP and this port is DP. And this port is RP and this port is RP. We'll check for this. Now you can check here. Before that, both are in designated ports and designated port. Port role is designated. Here you can check. This switch, designated port and this designated port, both are in forwarding state. In this switch, one is designated port. This one is RP. This one is RP and this one is DP. Only in one switches, only we have a one RP only. Can verify it here. For this switch, show spanning tree. See, 02 is designated port and 1 is, this is also root port and root port also forwarding and receiving. This also forwarding state only. And cost is 19. Why this switch is blocking state? We'll check. So spanning tree. This port is went blocking state because based on the forwarding port, this F0/1 and F0/2 based on this. Okay, anyone doubt? Anyone have any questions? Okay, fine. If you don't have any questions, we'll move to the. We have types of STPs. In types of STP, we have one is CST, second one is PVST, and third one is PVST plus. And CST is a open standard and PVST and PVST plus both are in the Cisco proprietary. CST, it's a open standard, means in different switches also it will work. If it is open standard means it will work in all these non-Cisco switches also, and the PVST having like CST, it's an open standard protocol, and in IEEE standard is 802.1D CST, and it operates a single instance of STP for all the VLANs. As I mentioned, in we saw VLAN 1, VLAN 2, VLAN 3, VLAN 4, we have a multiple VLANs, multiple instances. It will be work as like only one instance. Does not support it. It will be not support the load balancing. If we have multiple VLANs, VLAN 10 and VLAN 20, will send this port as a VLAN 10 and this link as a VLAN 20. We cannot use likewise. It will be not support the load balancing. CP utilization is very high for STP, CST. Guys, any doubts in CST? See, this is a CST. It's a common spanning tree protocol, and it's a per VLAN spanning tree protocol, per VLAN spanning tree plus. These two are, this is the spanning Cisco proprietary. This is the open standard. It will work all the switches, and this will work in only Cisco switches. So even though we'll use this is as a non-Cisco devices, because most of the organization will use Cisco devices. In that Cisco devices also, most of the organization PVST plus will use. And apart from that, PVST will having the same things what we discussed, same port roles, port based, these things only. Route bridge election will be likewise only, route port also, and cost also same, designated port, route port election will be happen likewise only. Here I am explaining CST. CST, common spanning tree protocol. It is an open standard protocol, and it having the 802.1D IEEE standard, and it operate single instances. How many it will be? We have the multiple VLANs also. It will be considered as a only one instances. But now move to the PVST. Here we can do the load balancing also. If we have hundreds of VLAN, if we have 100 VLANs, if we have 100 VLAN, in that 100 VLAN, we'll use here 50 VLAN for this link, for 50 VLAN for this link, 50 VLANs for blocking this state, and 50 VLAN for blocking this state. That is the load balancing actually. In this case, we cannot use. In these two cases, we can use. And per VLAN STP, see, it will be create per VLAN instance. So if we have VLAN 100, right? So here we have VLAN 100. So we have a like multiple switches. 100 VLANs, VLAN 20 VLANs. For this is a root bridge. For this one is a root bridge for 20 VLANs. 20 VLANs for this is the root bridge, and 20 VLANs for this is the root bridge. 20 VLAN for this is the root bridge. Per VLAN spanning tree, here we are doing per VLAN spanning tree. This also root bridge, and this one also root bridge, this one also root bridge. If any topology changes occur, that time entire topology will be happen. So it is a problem also is there, CPU utilization also more, that is the reason. Understood? PVST, per VLAN spanning tree. It operate separate instances for each and individual VLANs. It support load balancing also. How we are doing load balancing? Likewise, for different VLANs for different switches. We have 100 VLANs means we'll use 20 likewise. And we have a PVST plus. It will be work only ISL, not in .1 queue. PVST plus will work at .1 queue also. Apart from that, if you are using here HP switch and here you are using Cisco switch, Cisco one. So in between neighborship will not happen in PVST. If we are using PVST plus, then neighborship will be happen. They will, if this is the root bridge, you can assume, then it will be RP and this one is the blocking port. This is a DP. This is a DP. But if you are using PVST, it won't work. If you are using PVST plus, it will be work. In real time, we are using PVST plus only. Again, we have a RSTP, Rapid Spanning Tree Protocol, RSTP, Rapid Spanning Tree Protocol. Here, every entire thing what we discussed is same only, but it is a fast convergence. Rapid Spanning Tree having the RSTP, Rapid Spanning Tree Protocol. Rapid Spanning Tree Protocol. It is a open standard protocol and it is using IEEE standard, that is 801. So 802 only. 1W. CST also open standard and here also open standard. But in real time we'll use PVST plus and RSTP in Cisco devices. If you are not Cisco devices, that is RSTP only. RSTP only in real time will use. If it is not Cisco device, it's because it's an open standard protocol. It has fast convergence. Why? Because it having the only port states like port means here we are having the 5 states, right? In 5 states, here we have the only discarding, blocking, and this is a 2 will move to the, and this also discarding also. These 3 will move to the here we discarding state. And listening not there. In listening it will be 15 second, it 20 and 15 second gone. Then learning state is learning only. Learning is there. And it's take 15 second. Only 15 second fast convergence, and we have a forwarding state. Apart from that, forwarding is forwarding only. Forwarding is forwarding only. This is a RSTP, rapid spanning tree protocol. So that is the reason it's a fast convergence. And here we have the port states are so different. Here we have like earlier what we have here DP, and DP we call it is that DP only, and RP we call it as a RP only. Alternate only. One more backup also is there. If alternate is goes down, second we have a backup port, backup port role. Those are the difference. Apart from that, say entire thing is same. BPDO packets originated, same thing. RST. Oh, it's like everything is work. Same thing. And in we have here two types of protocols, like RSTP, it's open standard, and as I mentioned, PVST plus and RSTP. We call it as a this protocol entire thing. We call it as a RPVST plus. We'll use in real time this protocol RPVST, because PVST only the protocol, it will be work in Dart1 queue also, and we can enable load balancing also. If you are creating here hundreds of VLAN also, if you are using multiple VLANs also, that time it will be work. I'll show you in the lab. Any doubts in theoretically in RPVST, RSTP? Again, I am telling RSTP, Rapid Spanning Tree Protocol. It is an open standard protocol. The code is IEEE code is 802.1W, and it has the fast convergence based on the port role and based on the states, and root bridge, root port and designated port. Elected criteria is same as like STP. What we discussed in STP, that same election will be happen. It having the by default port fast. Where we'll use port fast, I'll explain on next session. Or see port fast. Actually, this is the port fast. This is a switch. You can assume this is a root switch, and root switch having the end users. So end user, this is a always they are forwarding the frame with the help of DP, designated port. Always DP only, designated port. Every port having this DP only. This entire, this one also DP, and this one also DP. So it will be take 30 seconds. 30 seconds because learning listening states. So for that, whenever if you don't want to waste for this LAN user, not required also for STP. Here STP required or not? You will tell me. Here STP is need or not? This is not a switch. This is not a L2 device. STP is required or not? Guys, are you listening?
Can you repeat?
It's required.
Mirza, what is said?
STP is required, I think.
This is a PC, and this one is a PC, and this one is a PC, a host devices. These all are the host. At host connection, if you are using here switch, this is a root bridge. It will be originated the frame, and it will be originated the frames, broadcast the information, then loop will be occur here. But it's a physical layer device. It will be not originated any frames. PCs not will be originated any frames. They will work on bits. Bits means 0, 1, 0, 1 likewise. They are in the data plane only. Data plane means end users are using these PCs. So here not required the STP because there is no loop right in between. Any loop occur? Even though switch is sending the packets, if they want, they'll receive. They will, whenever they are giving the reply, that time unicast only. Whichever MAC table they are maintaining, that time it will be do the unicast only. Here not broadcast frames will be occur here. End users. Even if not occur also, it is waiting for the broadcast that states only. Listening state will work. Listening states will be work here because DP is assuming like this is the switch only first time. So that is the reason.
It will assume first it will switch, then it will go to learning stage or listening stage,
Yes.
then blocking stage, and then it will
Yes.
go to disable.
Yes, when you see in lab also, whenever you are connecting one PC, that time it will be showing likewise only, right? Take one PC. See, this port role is green color only. After 30 seconds, the port will be moved to the, see, you can check here, show spanning tree. This port is now listening state, F0 by 3, F0 by 3. Now learning state, still learning state, 30 seconds it will take. Here, the BPDU packets are sending the packets. Now learning state, it will be learning state. The port is came up. Now forwarding state. See, now forwarding state. It was taken the 45 seconds only. So not if you don't want to waste that much time, we have a concept that is port fast. That is the port fast. So,
This port fast and port channel both are same.
sorry.
Port channel and fast both are same.
No, port channel is ether channel. That is the different concept. Entire thing is that is for load balancing purpose we are using.
Okay.
Ether channel. If you are using in between switches, that is next concept. If you are using like multiple connections, in between we are wasting our physical cables. So we have a concept. I want to use entire physical connectivities. So I'll make it as a port channel. The port channel, it is logically, they are working as a only one connectivity. They are all are the logically one only, but physically 1, 2, 3 cables. Logically, this is the only one cable. We'll make it as a likewise. See here, two are blocking. So I don't want to waste this physical connectivity. That time we will use port channel. So port fast and port channel is different concept. Port channel and port fast is different.
Okay. Okay.
So what I'll do, configuration and spanning tree. So wait. interface fast Ethernet 0/4. Spanning tree port fast. See, came up, right? And within a second it came up. So I don't want to waste. We'll use in real time this connectivities as a port fast. So in rapid spanning tree, it is required. Port fast is required. Why I am mentioning here, port fast is required in rapid spanning tree whenever you are using.
It
And
can be used between
RSTP is
sectors also.
no, not at
Only
end
between
users.
the devices, like
End users
end
only.
devices. Okay.
Yeah, here we are using uplink fast and backbone fast. Those are the different.
Okay.
Uplink
Okay.
fast and backbone fast. Here in this case, in between, we'll use. In this case, if any topology changes occur, this port. So before that, I'll remove this. Sorry, these two connectivities I'll remove because no, not required. So here, so see, by mistakenly I removed a different connectivity. Again, election criteria will be happening here. Show spanning tree. Now listening, learning. So fast Ethernet 0/4, and this is a fast Ethernet. So it is came up. What I'm mentioning here. So backbone fast and uplink fast, right? So what happened? We have a topology changes here occur in three ways. Three types of topology changes occur in STP. Three types. First one is insignificant. Insignificant means any end host will come. Any host will become. That is there will use port fast. If we don't want, that is here we'll use the port fast configuration. If we multiple user will be unnecessary, sometime it will become, right? So this is also topology change occur here. So we don't want to waste our time. We'll use as a port fast. And one more, this is the insignificant topology change. One more, direct topology change means this port went down, or this port some reason this port is goes down and this port is want to move up. This is called it as a direct topology change. Direct topology change. Okay. Again, this port came up. This port came up. This port want to move to the down only because the compared to election criteria, this port having the less port priority. So here it is a indirect topology change. Indirect topology change. In this case, we'll use uplink fast. We don't want to waste our time at 30 seconds. Again, election criteria we required or not? You tell me. Everything is happened. This
Yeah,
user
I get it.
don't want to waste the time. So we have a concept to uplink fast. Here we having the concept to backbone fast. We'll implement this backbone fast and uplink fast here. If anyone asks to you, that is the definitions only. Whenever the indirect topology change occur, we'll use it as a command that is backbone fast. If whenever the blocking port move to the up, the topology changes will occur again. It will be take 30 to 45 seconds. If I don't want to waste this much time, we have a concept that is uplink fast. And any end user join to fabric or any topology, LAN topology, one new user join to topology at end host. So here we call it as a insignificant topology change. So here we'll use port fast. These all are the interview questions. What is port fast? What is uplink fast? What is backbone fast? Guys, if you are not understood, I am ready to explain again. These all are the topology changes. Whenever the topology change occur, we are using backbone fast, we are using uplink fast, we are using port fast. And insignificant topology change occur at LAN users, at host side, will use port fast. If any direct topology change occur, means here you can see this port is goes down, then the port is want to come up. It is a direct topology change. Here we'll use, don't want to waste 30 to 45 seconds, then we have a uplink fast. And this port is came up again. It's indirect topology change. Indirect means previous topology, same thing only. So we'll use, I don't want to waste 30 to 45 seconds. So here we have a backbone fast. This much for this. This is the by default enable in RSTP. This is all about RSTP. And we'll use RSTP. It's a open standard. So we have a, in Cisco devices, we'll use this kind of PVST plus RSTP for VLAN spanning tree and RSTP. In real time, we'll use this protocol only. Any doubts? Guys, if you have any doubts, I will discuss.
Like,
Otherwise,
in like this backbone link and this uplink, they are directly executed using this protocol, sir. Like we don't need to assign it. Like we don't need to enter this. Like
this one, if you don't want to this kind of things.
yeah.
Yes, by
Like we
default
don't need
it
to
is not. By default, this kind of thing not enabled in real time.
Okay.
By default, it is not enabled. We should have to enable port fast also. But if you are
Okay.
using RSTP, you should have to enable, because RSTP is a fast convergence protocol. So RSTP don't want to waste 30 seconds. That is the reason STP is a wasting of time, 45 seconds. So we have a, that is the reason latest version is RSTP, rapid spanning tree. In real time,
Yeah,
we'll use RSTP only.
Yeah, that I got
So
it.
we do.
That I got it. Yeah. I thought like using RSTP, it will directly enable this if there is any kind of this kind of fields like backbone or this.
That is depending on topology changes. That is, you should have to know. That is the reason I explained these things. But we should have to enable this kind of thing. And this is the interview question also. Backbone fast, uplink fast, port. This port fast definitely they'll ask. What is port fast? If you are giving L2
So
interview,
these things we
definitely
directly we enable it.
we are enabling it.
Okay.
We have to
Okay,
enable it manually.
Wait,
right?
I'll stop the recording. We'll discuss more thing.
Oh.
If you have any questions related to this, we'll discuss. Otherwise, I'll stop the recording.